Hey everyone, welcome back. Today I'm doing a follow-up video on the previous couple of videos I made where I took a look at developing games for the Mattel Aquarius computer, and I actually did complete my first game, as I mentioned, which is this one here, Dungeon Quest for the Mattel Aquarius, and it's available now for download on my itch.io site. It's an adventure game where you control a character trying to regain control of your kingdom, and I really made this game as a demonstration of what type of games could be made now with the modern development tools that we have available for the Mattel Aquarius computer. So hopefully some of you might be inspired to make games yourselves for the Mattel Aquarius computer. I think it's a really exciting time to try and develop some games for this computer now that we have these modern tools available for us. So today's video is going to be about learning to program for the Aquarius in Z80 assembly language and machine code. The game that I made is written actually entirely in BASIC. I think it came out very well, and it produced a good result from just using the BASIC on the Mattel Aquarius computer. Now, I used the version of BASIC called USB BASIC, which is the version that comes installed with the micro expander device that you can get for the Mattel Aquarius computer. And I'll just show you the one that I have here. So this is the micro expander that I have for my Aquarius. And this one, you can see it's actually built into a little enclosure, which is kind of neat. And it has the ports on the back there. This is a port for the controllers, where I use actually an adapter cable to control my game using a regular Atari style joystick like this one here. And the adapter cable allows you to use 2 buttons on your joystick, as well as the 4 directions and 4 of the diagonal directions as well. And so this is the micro expander device that I designed that game for. And it's just in this little housing thing. So you can design games for the Mattel Aquarius using a micro expander device such as this, which I discussed in my previous video gives us extra memory and these ports that we can connect to. It has an AY sound chip built in as well, and gives us, of course, functionality for loading and saving data onto a USB stick. And my game actually comes on a USB stick. So this is how my game looks. It has a USB stick for the data. So it's a very easy way to use a game on the Mattel Aquarius now that we have these wonderful tools available for development. And so that's the game that I made, and again, it's for the Mattel Aquarius with the micro expander device, or we now have the MX device, which also has the functionality of the micro expander built in. And if you want to develop games or play games designed for the micro expander, we don't actually need to purchase a physical Aquarius computer. We can use the wonderful AquaLite emulator, which also emulates the functionality of the micro expander device. So in today's video, I'm going to cover a topic that probably very few people on the planet are even interested in, but for those of us that are interested in it, I think it's good to cover it because there's not a lot of information, from what I can see, really readily available for covering this topic, which is programming in Z80 assembly language and machine code for the Mattel Aquarius. Now, I should warn you up front that today's video is going to be quite long and detailed, and you will need to have at least some understanding of assembly language for the Z80 microprocessor, and of course some introductory knowledge of microcomputers, 8-bit computers, the computer architecture, and how programming on these computers works in general. And I've made some previous videos that might help you out if you need to kind of brush up on any of that information. You can go ahead and watch those if you like. But in today's video, like I said, we're going to be taking a look at how to program in assembly language and machine code for the Mattel Aquarius computer. Now, I should also say that I'm not an expert on any of this stuff, particularly not in machine code or assembly language, and I'm just going to be sharing with you today some of the methods that I was able to get working for myself that I can use for developing machine code for the Mattel Aquarius. And you can try it out if you like as well. All of the tools that we'll be using today are available free for download off the internet. You can download them and try them out and see how you like them, see if they work for you. So you can actually start developing games for the Mattel Aquarius with the micro expander functionality absolutely free. And of course you can donate money for these tools if you like, and you can register the tools if you like them. You can pay for them. Some of them do allow payment, but like I said, you can start absolutely free and just see how you like it and kind of test it out. So like I said, today's video is going to be a long one. It's going to be very detailed because we're going to be looking at not just setting up the development environment, but also some of the quirks of the Mattel Aquarius that we need to be aware of in programming using these methods. And like I said, I'm not an expert in any of this stuff, but I'm just going to share with you what I've been able to get working on my system. So I'm going to start out actually with the simplest method that I feel is the easiest if you just want to get started right away and write a very simple assembly language or machine code program for the Aquarius. And then we'll kind of build from there up to a development environment that I think is the one that I'll be using for developing games for the Aquarius in assembly language or machine code myself. So if you're ready to get started, we'll go ahead and I'll change my screen over to the screen sharing mode, and we'll go ahead and take a look at how we can program machine code for the Mattel Aquarius. Alright, so we'll go ahead and get started here, and the first thing I want to mention is that I'm going to be setting up this development environment on a Windows PC environment. So I'm not sure if these tools will work with a Mac or Linux, but I'm going to be setting this environment up on a Windows PC, so I should let you know that ahead of time. So if you're wanting to follow along with me, then these tools are designed to work with Windows. So I'm going to go ahead and get started here. And actually the first method that I'm going to show you for developing a machine code program using Z80 assembly language for the Mattel Aquarius is actually using a tool that I have showed you in my previous videos. I've been using this for developing games for the Sinclair Spectrum computer. It's actually the ZX Spin integrated development environment, which includes both an assembler and an emulator, a Sinclair Spectrum emulator, as well as a debugger all in one package. Now, why do we want to use a tool that's designed for developing programs for the Sinclair Spectrum computer when we're looking at programming for the Mattel Aquarius? Well, we should probably start off by taking a look at and discussing exactly what the process is for making a machine code program for the Mattel Aquarius. And when I say machine code program, it could be a subroutine that you use as part of a basic program, or it could be an entire machine code program. If you want your program to be entirely in machine code, it's up to you exactly what you want to use this machine code functionality for. But the main process that we're going to be using is we need to create our program in some sort of editor, a text editor, and then we need to convert that program into machine code by assembling it. So we need a text editor for entering our program, we need an assembler to convert that program into a machine code program, and then we're going to be executing that program either in an emulator like I'll be showing you today, or you could copy that program to a USB stick and put it into your micro expander device on your actual physical Aquarius computer if you like. The games that I'm making are going to be specifically designed for use with the micro expander device or the Aquarius MX, which also has the functionality of the micro expander device, or using the AquaLite emulator that has the micro expander functionality built in as well. So having said that, some of the methods that I'm going to be showing you today don't actually require the micro expander functionality, and we'll be discussing that as well. So first, let me just start off with what I think is the simplest method for creating a quick assembly language program for the Mattel Aquarius, and that is by using this ZX Spin integrated development environment. Now, I did make a previous video explaining all about how to install this tool and how to use it. So if you're not familiar with the ZX Spin environment, it's very easy to download and install, which is why I'm recommending it, because I was able to install it and get it working very quickly. There's not really any setup you need to do with it, so that's why I'm recommending it, because if I could figure out how to do it that quickly and easily, then probably you can too. So what I'm going to do is bring over my ZX Spin environment that I have installed. And when you start up the ZX Spin environment, it opens up this emulator, which is an emulator for the ZX Spectrum line of computers. So don't worry about that. We're not actually going to use the emulator for the Sinclair Spectrum in this environment. It just opens it automatically when you start the program. But I'm just going to take this off the screen because we don't need it. But before I do that, what I do need is the assembler, because we're going to be using the assembler tool in this ZX Spin environment for creating our first simple assembly language program, and you'll be amazed how quickly and easily it is to actually do this. So we are going to need to cover some detailed topics to familiarize ourselves with the certain aspects of the Mattel Aquarius, in particular things such as the memory map, so we can figure out where we want to store our machine code programs. And we'll be looking at some technical info along the way, but we'll be taking it step by step, so hopefully it won't be too confusing. But let's get started with the simplest method for creating a machine code program or an assembly language program, which is using this ZX Spin environment. So here I have the emulator open, you can see, and from within this emulator window, I now need to open the assembler that I'll be using to type in the program. So the way I do that is I go to Tools, and then at the bottom here it says Z80 Assembler. And I'm just kind of cheating by doing this because I'm just using any Z80 assembler that I happen to have on hand, and it worked. So I'm going to show you how I did it. So here, let me just get rid of this emulator window here, which we don't need. And here is our assembler window where we can enter in our assembly language program. Now, before we do this, I'm just going to go back to my OneNote page here where I have all the notes that we're going to be following for doing these different methods. And you can see my first method here is titled ZX Spin plus micro expander method. So we'll just go through this step by step. And the first step here says type program into ZX Spin assembler. And you can see here I have a simple assembly language program that I've entered here into my notes, and this is the program that we're going to be using. So let's first take a look at this program and see what it does. But before we take a look at exactly what the program is going to be doing, let's take a look at some of these other notes here I have that describe why we're using the ZX Spin in this particular method, the ZX Spin integrated development environment. So some of the features of it, or the attributes of this ZX Spin environment, are here. You can see it says designed for Sinclair Spectrum, which also uses Z80 microprocessor. So since we're making an assembly language program for the Z80 microprocessor, then this tool is going to help us do that because it's obviously designed for the Z80 as well. The second note I have here, it says it's easy to install and use. Like I mentioned, I was having no problem downloading it and installing it. So easy to install and use is perfect for me. So that's why I'm recommending you might like to try out this tool as well. And then finally here, there's a note that says includes disassembler. And We don't necessarily need to use a disassembler at this point in our journey, but it's a cool feature to have if you want to take a look at the memory locations and the contents of those memory locations and what assembly language instructions those memory addresses convert into. It does have a disassembler and a debugger actually built in. We won't be using the debugger functionality of this tool because, again, we're not designing a program for the Sinclair Spectrum computer, but it does have a disassembler if you just want to examine the memory locations. So those are some of the positive aspects of this tool and why I think it's worthwhile taking a look at. So now let's take a look at the actual program that I'm going to be entering today into this environment and see what it's designed to do. So if you have any understanding of Z80 assembly language whatsoever, this will be a very easy program for us to examine. And let me just expand this a bit so it fits okay there. All right, so this program is very simple. It has only 3 lines of code. The first line here that says LDA, 25, that simply loads the decimal value 25 into the A register. And it says here, load character code for robot symbol into accumulator register A. See manual or Aquarius Draw. Now, what does this mean? Like I said, we're going to be looking at some detailed information about the Aquarius, and we're going to be starting off with this one here. So the first thing let's take a look at is the Aquarius manual and see what this 25 value is being used for. All right, so here I have the Aquarius manual open on my screen here. And what I want to do is go down to the section that shows the different characters that are used on the Aquarius. As you may or may not know, the Aquarius computer uses a built-in character set. It has no user-definable graphics whatsoever. So we need to use the character set that is built into the computer. So let me just go down to the section that shows the character set. It should be down near the end here somewhere. Right here. So here are the characters that are built into the Mattel Aquarius computer, and it shows you the symbols combined with their code. So the number that we're looking for is 25, and you can see it's right here, 25. And so these are all the different symbols that this computer can generate and the different codes associated with them. And the one that we're looking at, like I said, is 25, which is right here, which corresponds to this little robot symbol. So just keep that in mind. This is the symbol we're going to be looking for when we actually run our program. Now, another way that we can take a look at what this number means is, if you see my note here, it says load character code for robot symbol. And as we just saw in the manual, the code for the robot character is 25. And it says here, see manual or Aquarius Draw. Now, as I mentioned in a previous video, Aquarius Draw is a fantastic tool developed by Matt Pills that allows us to very easily generate and design full screen graphics for the Aquarius. And I'm just going to bring it up here. And so when you go to the website, which is the Aquarius Draw tool, it's an online tool that's accessible through Matt's website. And when you go there, this is what you will see. You'll see this backdrop here that allows us to create graphics for the Mattel Aquarius. And as I briefly mentioned in a previous video, we simply select a graphic we want to draw over on the left side, and then we can draw it on the screen however we like. But what I want to look at here is one feature of this Aquarius Draw tool, and I'm just going to zoom in a bit so we can take a look at all these characters over on the left side. And I'm going to right click now on my mouse, and you can see there are 2 selections here. One is sorted layout and one is original layout. The sorted layout is the one that we're seeing now, which groups the different symbols in kind of a logical sequence, that it groups similar characters together so that it's very easy to figure out which character you want to use just by the way that they look in relation to other characters. But what I need to do now is select this original layout by clicking on it here, and it reorganizes these patterns by their code value because I want to look for that specific code number 25. So if I go up here and I look for code number 25, which should be that little robot symbol, which is right here. You can see if I hover over it with my mouse, then it brings up the code for that character, which is 25. So I just wanted to show you this method for finding the codes for the different characters as well, in case you prefer to do it that way. It's another great tool at our disposal. And now let's go back to my list right here. So now we should be able to understand what this first line of code is doing. It's loading the value 25 into the A register, which is the accumulator, and the value 25 represents that little robot symbol that we're actually going to be printing on the screen. Okay, so now let's take a look at our next line here, which says LD, or load, 12288, comma A. So if you know machine code or assembly language, then this will be very easy for you. This is simply going to load whatever value is in the A register into a memory location, which is specified here in brackets. The brackets specify a memory location, and this memory location that we're interested in is 12288. Now, why are we interested in this particular memory location? Well, it turns out this is a very special memory location for the Mattel Aquarius, because the way the Mattel Aquarius works, as you probably know, it uses these character graphics as well as a character RAM matrix and an attribute RAM matrix. Now, if these terms don't mean anything to you, don't worry, I'm going to explain them right now. So let's take a look at the user manual again, and we can see what I'm talking about here. Alright, so here's the user manual we were just looking at, and now I'm just going to go to a different section of the manual that shows us how the memory is laid out in terms of being able to print characters and colors to the screen. So let me just find that section here. Which is right here. So you can see this page is titled Character RAM Matrix, and this matrix that we see on the screen here, these represent memory locations. And if I zoom in here, you can see that this starting location is 12328, and the way this works is the character RAM matrix is essentially a bunch of memory addresses that will contain characters that will be printed on the screen. So if you put a particular value into one of these memory locations, then that character that corresponds to that value will appear on the screen. And we can actually try that out in the emulator. If we want to just test it out quickly, we can do that now. I'll just open the AquaLite emulator, and let's see what happens when we put a value into one of these memory locations within the character RAM matrix. So why don't we just pick this first one here, which is 12328, and you can see that these memory locations also correspond to the different printing locations on the screen. You can see these numbers here counting from 0, 1, 2, 3, 4, 5. These are the row and column numbers for these character positions on the screen, but they also correspond to memory locations. So this character position here, 0, 0, corresponds to this memory address 12328. So what happens if we poke a value 25 into that memory location 12328? Let's try it out. So I'm going to poke 12328 with a value of 25. And there you can see our little robot symbol shows up in character position 00, row 0, column 0, which corresponds to this memory location 12328. Now, there is something else we need to be aware of, which is the Mattel Aquarius computer also has a hidden row of characters at the top. So even though on this page of the manual it shows that the first memory location for the screen character display starts at 12328, there's actually a hidden row above this line. And if we look at my notes here in Microsoft OneNote, I have some notes that I've made about the graphics, and here I have my own notes about the character RAM matrix, and you can see my note here says that there's one hidden row at the top starting at 12288. So there is another actual row of characters above this top row of characters shown in the manual, but they're not shown there because you can't actually position the cursor there to print anything there. They don't have a row and column position defined for them. It's a hidden row, but it's a very useful hidden row, and we might as well make use of it, right? So let's take a look at that top hidden row of characters. And before we do that, let's just take a look at my second note here that says the character poked into 12288 will also fill the border. So there's an extra row of characters up here at the top, and the very first one, which corresponds to memory address 12288, whatever character you put into that location will also fill the border of the screen. And before I go any further, let's just take a quick look at the color RAM matrix, which is the attribute matrix. We're not going to be using this in today's video, but just to let you know, there are also a set of memory addresses which correspond to the same locations on the screen, but when you poke a value into those memory addresses, instead of printing a character on the screen, they determine what color is going to show up in that position on the screen. And of course, there's also a hidden row of color attributes for this matrix as well, and they start here at address 13312, and it says here the color poked into 13312 will also fill the border. So this first position in the hidden row is very important, because whatever value we put there, either in the character matrix or the color matrix, will also fill the border on the computer. So why don't we give that a try, just doing it manually for now. So let's go back to my character RAM matrix, which is right here, and it says the first value in the character RAM matrix in this hidden row is at address 12288. And let's actually go back to this Aquarius Draw tool that we took a look at a moment ago. All right, here it is right here. And there is an option here that we can use that will help us to take a look at what we're talking about right now. If I right click here on the border, I get these two options: reset border and disable row 0. So row 0 is that hidden row that I was just talking about, and you can enable it or disable it in this Aquarius Draw tool as well. So here I can disable it, and then it doesn't show up on the screen, or if I right click again, I can enable it. And if I zoom in there, this is a bit easier to see. So here you can see this top left character is part of that hidden row, and if I turn it off by disabling it, that entire row goes away. So if I put a character, let's say, into this top left hand character position now in this tool, let's say I'll choose this copyright symbol here. So here we have a copyright symbol, and if I put it into this position, it goes into that position, but it doesn't affect the border because it's not in the hidden row. So let me go ahead now and enable that hidden row in this tool, just like this. And now you can see the hidden row pops up. And what happens if I put this copyright symbol in the top left hand position of this hidden row? There you can see it fills the entire border. And if I change the color attributes, then those colors also fill the border. So this is a very cool little square to be aware of, that whatever you put in that square, in that memory location, either the character memory location or the color attribute memory location, that will fill the entire border. And that's exactly what our program is going to do today. And just be aware that it's only the leftmost position of that top row that affects the border. If you put a different character, let's say, into any of the other positions on that top row, they don't affect the border whatsoever. So it's only that top left position that affects the border. So now let's go back to our assembly language program right here, and we can see what we're doing is we're loading that value in A, which we now know has a value of 25, which corresponds to that robot character, and we're going to poke that into, well, not poke it, we're going to load it in assembly language into this top left hand position for the character RAM matrix, which is at address 12288. So whatever character or value we put into this memory location will fill not only that location but also the entire border. And so now let's go back to the emulator right here, and let's just try doing that manually. So this time, instead of poking 12328, I'm going to poke 1 12288, 25, and let's see what happens. There we go. So this robot symbol, which has a character value of 25, since we put it into the top left location of that hidden row, it not only fills that character position, but that character also fills the entire border. And that is what our assembly language program is designed to do. So let's just go back and take a look at that, and we'll copy this assembly language program now that we know what it's designed to do. All I'm going to do is simply highlight it and press Ctrl C to copy it. And then now I'm going to go back to my ZX Spin assembler, and I'm going to paste it in. So here we have our Z80 assembly language program pasted into our ZX Spin assembler. And now what we want to do is we need to assemble this program into machine code, and this ZX Spin assembler is going to do that for us. So let's go ahead and do that now. All we need to do that is go up to File and Assemble. And when we do that, it actually opens this other window here. And this is where we're now going to look at some more technical information about the Aquarius computer, because we need to figure out where in memory we want this machine code program to live. And you can see here in this window, this selection here says memory and start address. So I could, if I wanted to, indicate a starting address where I want this machine code program to live once it gets assembled and converted into machine code. But in this case, I'm not going to do that, because I'm simply going to assemble this program into a file that I'm going to load into the emulator. Or you could run that file on your actual Aquarius computer if you like. So in this case, I'm not going to save it to memory, but I'm going to save it to a file. So let's click on binary file here, because it saves it as a binary file type. And then I'm going to save this file somewhere. Now, if you've used the AquaLite emulator, or if you've watched my previous videos, I briefly mentioned about how the AquaLite emulator has the functionality of being able to save and load data and programs to a USB stick. And the way it does that is it has a folder that's called USB. So let me just go to my AquaLite installation folder here in my Explorer, and you can see here under my Aquarius folder, I have another folder called AquaLite 133, which corresponds to the AquaLite emulator version 1.33. And if I open that, you can see here there's a folder labeled USB. So this USB folder is where the emulator looks for files that it tries to access as if it were accessing them from a USB stick. So what I want to do is save my machine code program into this USB folder, because I'm going to be accessing it from the emulator as if it were on a USB stick. So you could either save this file to an actual USB stick and then run it on a physical Aquarius using the micro expander device. But in my case, I'm going to be saving that file directly to this USB folder, because I'm going to be accessing it from the AquaLite emulator. So I'll go ahead and do that now. So back in this window where it's asking me where I want this file to be saved, I'm going to click on this folder here, and I'm simply going to find that USB folder, which is under my Aquarius folder, AquaLite 133 folder, and then here it is right here, USB. So these are the other folders that are currently in this USB folder, but now I've got this USB folder selected, and I simply have to type in a file name that I want to save it as. So why don't I call it MC test1 for machine code test 1. So MC test 1, and I don't have to specify any extension. I'm just going to leave it without an extension and click save. So this is the file name and folder where it's going to be saved right here. It fills it in this window for us automatically. And now if I click OK, then that should now be saved in my USB folder where I've installed my AquaLite emulator. So let me go check that out. Here we are back at the USB folder where my emulator was installed. So if I open that up now, I should have a file that's called mctest1. And here it is right here, mctest1. So that means now our AquaLite emulator should be able to access this file because it's in the USB folder. So let's go back to the emulator now. Or actually, before we go to the emulator, let's go down our checklist again so we don't forget what we're doing. So the first thing we did was type our program into the ZX Spin assembler, so we can check that off. And now the next step says assemble the program and save as binary file in the AquaLite USB folder with no extension. So that's exactly what we did. We assembled the program and we saved it into our USB folder where we have our AquaLite emulator installed. So let's go ahead and check that off. And that's done. And now the next step says run the program from AquaLite with this basic program. So now what we want to do is, since we have our machine code program all ready to go, we can go ahead and run that program from either the AquaLite emulator or on the actual Mattel Aquarius. And the way we're going to do that is by using this basic program, which I'm going to go through now, because the process for running a machine code program on a Mattel Aquarius has some details we need to be aware of. And so we're going to go through these step by step and see exactly how they work. So this is a basic program that I'm going to be typing into the Mattel Aquarius, or in this case the emulator, which is going to allow me to run that machine code program that we just saved in the USB folder. So let's take a look at this program step by step and see how it works. All right, so the first line in our basic program is line number 10, AD equals 16,000. So what I'm doing here is simply assigning a value of 16,000 to a variable called AD, which represents an address where the machine code program is going to be run from in our emulator. And our note here says set variable to start of machine code program address. So we need to load our machine code program into some location in memory, and I've chosen to use this value 16,000, and we're going to take a look at that in a moment also, why I chose that value. And it says here in my note, see memory map to choose address. Program relocatable, if not, must match program. So before we take a look at the memory map, let's discuss this last note. Is the program relocatable? So what does that mean? So obviously when you're writing a program, programs will often branch and jump to different locations in the program. So if you have a program that you've written that jumps to a particular memory address, for example, with assembly language, the program can branch off into different locations. And if you want to have your program move to a different location and begin execution somewhere else, and you tell it where you want to jump to, just like in BASIC, you might say go to a particular line number. Well, in assembly language, you have a jump command where you can jump to a particular memory location where the computer will continue execution of the program from that location. Now, if you have a program that uses fixed addresses, meaning you tell the program you want it to jump to a particular specific address, then that means it's going to jump to that particular address, which means the program is not relocatable because it's going to be jumping to a specific memory location, in which case you need to make sure that wherever you load your machine code program into memory, it has to match up with the addresses that you've specified in your program. Otherwise the program will jump to the wrong locations in memory that don't contain the code that you want to execute. So in this program that we have here, you can see there are no jump statements, so it doesn't matter where in memory this machine code program is loaded. It's easily relocatable, so we don't need to worry about that. So I can go ahead and load this program into whatever memory location I want. So now let's go ahead and take a look at the memory map for the Mattel Aquarius and figure out where would be the best place to store our machine code program. So the way I'm going to do that is by accessing an online tool which is very handy, which is this website here, vdstenoven.com. And let's take a look at what it says here. So here, let's just take a look at the diagram and we'll zoom in a bit. It's a bit fuzzy, but I think we can still figure it out. Let's read some of the text to begin with, and we can figure out how the memory in the Aquarius works and what it's allocated for. So it says here, the Z80 used in the Aquarius computer can address up to 64K of memory. So that doesn't mean the computer comes with 64K of memory installed, which it doesn't, but it just means that the Z80 microprocessor can physically access up to 64K of memory. And let's see what else it says here. On the bottom, you can see that the Aquarius is using 8K ROM memory for basic. So let's zoom into our diagram here. All right, and here you can see there's a diagram that says 8K basic. So at the very beginning of our memory map, starting down here at location 0000 in hexadecimal, and going up to, in this case, 2000 hexadecimal, this represents 8K of memory, and that 8K of memory is ROM inside the machine. So this address space from 0 hexadecimal to 2000 hexadecimal is not available to us because it's being used by the ROM. Now let's go back to our text and see what else it says. It says, then there is a gap of 4K. This area is reserved for extended basic as used in the Aquarius 2 system, but not used in the standard Aquarius system. And here it says not used 4K. So there's another 4K chunk of memory down here that is not usable to us, or I don't think it's usable to us, at least, but even if it is, I'm not going to use it right now. So just be aware that there is a chunk of 4K memory here that is not used by the computer, and it comes after this 8K basic ROM chunk of memory that we just discussed. And let's see what the text says now. It says the standard Aquarius computer has been sold with 4K of RAM memory, but as you can see in the figure, 2K is already used for video memory, 1K screen, and 1K color. You can see above this not used 4K section, there's 1K that's used for the screen memory map, which we just took a look at. This is the memory locations that store all the characters that get printed to the screen. And then above that, there's another 1K section for the color attributes. This is the memory locations where all the color attribute information is stored. So whatever values are contained in this memory location will be showing up on the screen as well. So we can't use these 2K of addresses for our program, obviously, because whatever data we put there is going to show up on the screen. So let's see what the text says next. It says, according to the figure, the user has 2K of RAM, but actually an additional 256 bytes are being used for system management. That leaves 1.7K free usable RAM on the standard Aquarius and completes the lower 16K memory inside the Aquarius. So let's zoom in again one last time. Well, one last time for now. And we can see, as we discussed, the bottom 8K of memory is reserved for ROM basic interpreter. Then there's a 4K section that is not used. There's a 1K section used for the screen characters. There's a 1K section used for the color attributes on the screen. And then here we have a 2K section that is available for us to finally do our programs. And this is where we would, let's say we were writing a basic program. This is where our basic program would get stored in this 2K section of user RAM. But if we look at the note again, it says that 256 bytes of that 2K is being used for system management. So now we're going to take an even deeper look into the Mattel Aquarius, just for interest's sake, because I think it's kind of cool. And we're going to take a look at where is that 256 bytes of RAM being used. And in order to do this, we're going to take a look at the system variables. So as you probably know, these personal computers have something called system variables built into them, which is a bunch of variables that the computer uses to keep track of different things. And so it needs to have its own internal variables to keep track of all this different information that it needs in order to operate. And these 256 bytes are being used up by system variables and maybe some other management stuff. But let's go ahead and take a look at exactly how these 256 bytes are being used up. And to take a look at that, I'm going to look at something called, well, I'm going to look at the system variable list. And the way I'm going to look at that is in the ROM disassembly. So let's look at those two things individually. Let's first of all take a look at the system variables, which there's actually a link to them right here on this website. If we click on memory layout over here on the left, it brings up this list and it shows the different memory addresses in the computer and how they're being used for things such as system variables, for example. So we can see on the list here exactly how the memory layout is being used. and we just took a look at this on the diagram. So address 0000 to 2FFF is not addressable with peek and poke, it says, because that's the ROM where the basic interpreter is stored. And then it has the other addresses we just looked at: video and color matrix, system information, the start of the basic program. So let's take a look at the list of memory addresses here and how they're used for the system variables. So here you can see an address of 3800, which contains a value for this system variable called TTYPOS, and then all these different memory locations from 3800 hexadecimal up to, let's see, 38F8, they are reserved for all these system variables. And if we take a look at the decimal values, 14556 is the decimal value of this last system variable, and the first one is at 14336. So if we subtract those two using our calculator here, 14556 minus 14336 equals 220. So just the system variables alone take up another 220 bytes of memory, and that accounts for some of these 256 bytes that is being used up, that only allows 1.7K of free memory for our basic program. So let's go back to that diagram again. Right here we can see the user RAM, which is specified as 2K, but we now know is actually only about 1.7K. It goes up to the maximum of address 4000 hexadecimal, but actually 4000 is the starting address of the next section of memory. So the highest memory address available to us in an unexpanded Aquarius computer would be address 3FFF in hexadecimal. So let's see what value that is in decimal. And I'll just go to my programming calculator here, and I'll select hexadecimal, and I'll enter 3FFF, and you can see the decimal value for that is 16383. So 16383 is the top address that we can use for our program, either basic program or machine code program on an unexpanded Mattel Aquarius computer. And if there's about 1.7K available to us, so 16,383 minus about 1.7K, which is roughly 1,700. So 16,000 minus 1,700 is about 14,300. So roughly this is where our program would start. So we want to be somewhere between about 14,300 and 16,383. So since we're going to be using a basic program to run our machine code program, that basic program is going to take up some memory at the bottom of this space as well. So let's put our machine code program near the top of this available space in an unexpanded Aquarius. And since our program is very short, let's put it at address 16,000, and that gives us 383 bytes to work with, which we won't need anywhere near 383 bytes. So this is a very good location to use for our example, I think. We'll put it at address 16,000, and if I go back to my checklist now, you can see that's the address that I've chosen for my beginning address for our machine code program is 16,000. So the first line of this basic program assigns a value of 16,000 to this variable called AD, which is our address where our machine code program is going to be stored in memory. All right, now let's take a look at the rest of our basic program, which we're going to use to run our machine code program. So the next line here says high equals int AD divided by 256. So what we want to do here, just before we look at these program lines in detail, these next four lines, what we need to do is actually use one of those system variables in order to help us run our machine code program. And just to give you a preview of what's coming up is if we take a look down here at the last line of our program, it shows a command called USR. So this USR function, which we're ultimately going to be using to run our program, and you may be familiar with perhaps running machine code programs on the Sinclair Spectrum computer, which uses a randomized USR instruction to run its machine code. In this case, we're using a USR function as well, but in order to use it, we have to set up a system variable with a value that tells it where our machine code program lives. So this system variable has two different addresses associated with it, one containing the low byte of our machine code program address and one containing the high byte. So we need to figure out what those low and high bytes are. So let's go ahead and take a look at the ROM disassembly now for the Mattel Aquarius computer. And remember that ROM section of memory we looked at in the memory map? Let's go ahead and take a look at the disassembly of that now, and we'll see exactly what is stored in that ROM. And it's right here. So the way this works is it shows us the different memory locations inside the computer. And you can see here, for example, there are hexadecimal addresses indicated, 3000 hexadecimal, 3400 hexadecimal, and so forth. So what we want to do is find the system variable that is going to help us run our machine code program. And if we look back at my list here, you can see I'm using these two addresses, 14340 and 14341 for the low and high bytes. So I know this might sound confusing, but if once you have this program entered into your computer, it pretty much runs itself. So you don't have to worry about all these details. You could just enter this program and use it if you like. But I'm just explaining how these instructions work. And so what I want to do now is take a look at this first address, 14340, which corresponds to a system variable in the computer. And I want to convert that to hexadecimal so I can find it on the list. So 14340, if I enter that into my programming calculator in decimal, 14340, that corresponds to a hexadecimal address of 3804. So let's take a look on the disassembly listing and look for this address 3804. All right, so here's my disassembly listing now, and 3804 would be where? 38 right here. 3804. So this address 3804 is a memory address that contains a value that corresponds to the location of our machine code program. So we need to tell the computer where our machine code program is in memory in order for that USR function to be able to find our machine code program in memory. And the way it does that is it uses this system variable called USR add or USR address, which makes perfect sense. We need to tell the USR function where the address of our machine code program is. And it says right here, address of USR routine, which is our machine code program. So what we need to do is put a value into these two memory addresses, 3804 and 3805, which correspond to 14340 and 14341 in decimal. And the values we need to put in those addresses are the low and high bytes of our 16-bit address where our machine code program is being stored. Now I could calculate these values manually using a calculator if I want, but I'm just letting the computer do it for us here. And the way we do it is by using these two instructions here. So here you can see I have an instruction that says high equals int AD divided by 256. So it says here in the note, calculate high byte for machine code start address. And so all this does is simply calculate the high byte of our machine code address by taking this AD variable, which we've loaded with the address where our machine code program is being stored, and the program divides that by 256, and that is the high byte of our address, and we load that into a variable called high. And so of course we now also need the low byte, and the way we do that is by using this formula. Here we take the address and we subtract the high byte multiplied by 256, and that gives us the low byte that we need to use in our system variable, and we assign that to a variable called low. So now that we have these two variables, high and low, that contain both our high byte and our low byte for our machine code starting address, we can use these values to poke into that system variable to tell the USR function where our machine code program lives in memory. So that's how this works. Now there is another note here that you might see. It says rem could also use low equals add and 255. So this is just an option for us. It's another tool we have at our disposal. Instead of using this formula here, add minus high times 256, you could also use this formula here, low equals add and 255. And maybe I'll just leave this as a challenge for you if you want to try and figure out exactly how this instruction works. It does exactly the same thing. It takes this 16-bit value that's contained in the add variable, and it extracts only the low byte from that by ANDing it with the value 255. So you could use either one of these two formulas. You could say low equals add and 255, or you could say low equals add minus high times 256. All right, so now we have our low and high addresses for our machine code program, and we need to poke that into the two addresses that represent that USR add system variable, which are at these two addresses here, 14340 and 14341. And that's exactly what these two lines of code do. They poke our low and high bytes of our machine code address into this system variable, which it says right here, poke low byte of machine code address for USR call, poke high byte of machine code address for USR call. And it says C sysvars, which we just took a look at the system variables. And so now the USR function should know how to access our machine code program because we've loaded the value into the system variable. So now let's take a look at our next instruction, which says load jtest2, AD. So this jtest2 is the name of our machine code program that we saved using our assembler. But remember, we saved it using a name called mctest1, right? So instead of jtest2, I'm going to change this to mctest1. And of course, it's not case sensitive. It doesn't matter if you capitalize it or not. So I'm not going to capitalize it. I'm just going to type mctest1, just like that. So what does this do? So remember, we're going to be running this program either in the AquaLite emulator with the micro expander functionality enabled, or on an actual Aquarius computer with a micro expander installed, or the Aquarius MX. And that's why it says here in the title that this method says ZX spin plus micro expander. So we need the micro expander functionality in order to use this load command here, because a regular Aquarius with its regular built-in basic doesn't have this load command for loading a machine code binary file in this way, which is why this method is used with the micro expander functionality enabled, which allows us to load our machine code program into the computer or the emulator. I'll just zoom in a bit here. It says 60 load mctest1, AD. And how this works is it loads our program, which is our machine code bytes now, and we've labeled it mctest1. Remember, we saved it in our USB folder. So this load instruction will be looking in the USB folder or looking on a real USB device if you have a physical computer with a physical USB device plugged into the micro expander. It's simply going to load our machine code program, and this AD tells it where to load that program in memory. So remember, AD is our variable that we set up here with the value of 16,000, because we want our machine code program to be loaded into memory at address 16,000, because we determined that's a good place to put it from looking at the memory map. So that's what this line does. It loads our machine code program into memory beginning at address 16,000. And then finally, the last line of our basic program here, it says x equals USR 0. So what does this mean? Well, what this does is it executes this USR function, which runs our machine code program, which is located at the address that we specified in this system variable USR add. That's why we poked these values into these two memory addresses, so that this USR function would know where to look for our machine code program. And that is what this function does. You simply assign it to a variable like this, x equals USR 0. And this function actually performs more things than we need to look at right now. For example, this x gets assigned a value that we don't need in this example, and this 0 value actually also has a purpose, again, which we don't need for this example. But just enter this line of code exactly how it is here, and this should execute our machine code program. So now that we have our machine code program saved in our USB folder, let's go ahead and enter this basic program into the emulator, and we'll run it and see if our program works. So I'll go ahead and open up my emulator here, right here. And again, this is the AquaLite emulator version 1.33, and it's good to just download the latest version of this emulator because there might be some older versions available that you may be already using. So I recommend you go ahead and install the latest version, whatever it is. I'm using version 1.33, and you can see here this is the regular startup screen for just a regular Mattel Aquarius without a micro expander installed. So I'm going to enable the micro expander functionality now by going up to Tools, Options, and then on the Peripherals tab there is an option called micro expander, so I'll check that on to enable it. And now when I click OK, this emulator reboots into the micro expander menu, which looks like this. So now if I press return on my regular PC keyboard here, I can either type in a basic program, or what I'm going to do is I'm simply going to copy and paste my basic program from my Microsoft OneNote, which is why I like using Microsoft OneNote so much. So I'll go back here to my OneNote and I'll copy these lines of code just like this, and back in my emulator, if I press Control V, that will paste it in. So Control V. So there's my program, and I can do a clear screen by typing CLS, and then I can list my program, and you can see there's my program. So we're assigning a value of 16,000 to this variable called AD, and then we're calculating both the high and the low bytes of our address where our machine code program is being stored. So we're breaking down the 16,000 value into its high and low bytes, and then we're poking those values, high and low, into these two memory address locations, 14340 and 14341, which correspond to the system variable called USR add, which tell this USR function where to execute our machine code program from. And then finally we're loading our program, load mctest1, add. So we're loading our machine code program that we previously assembled and saved into the USB folder into memory beginning at address 16,000, which is stored in this variable called AD. So before we run this program, let's just do a dir, which shows us the contents of our USB folder. And you can see here that there's several different things saved here, but one of those things is this mctest1 program that we saved, and it shows that it has 6 bytes. So we're going to go ahead and run this mctest program now from within our basic program. So let me get our basic program back on the screen right here, and line 70 is going to execute our program by using this command x equals USR0. So let's go ahead and run this program, and remember what it's supposed to do. It's supposed to put that little robot symbol in the top left section of the hidden line on our screen, which should also fill the border with that robot symbol. So let's type run now and see what happens. There we go. So we have our first assembly language program converted to machine code and run on the Mattel Aquarius. So it's just that simple. If you want to create your own machine code program, we can go ahead and change our program in the ZX Spin environment. Right here, here's our program, remember. If we want, we can go ahead and change this program now. Maybe we want to choose a different character. We can take a look at our user manual again. And here's all the characters now. We could choose a different one if we want. Maybe we want this right-facing arrow here, which is character number 142. So all we do is change our program. So instead of value number 25, we'll change this to 142, which corresponds with this right-facing arrow thing. And let's go ahead and assemble our program again by selecting File, Assemble. And it pops up this window here, and we're going to save it again as a binary file. And where are we going to save it? Of course, in our USB folder, which is, in my case, under Aquarius, and then AquaLite 133, and then USB. And now I enter a name for it. Let's call this one mctest2. And we'll save it now. And here it populates this window for us like it did before, and we can click OK here. And now it should save our program mctest2 into our USB folder. So let's go back to our emulator again, right here. And now if we do a dir, we should see our new program, mctest2, in there somewhere, which is right here, mctest2. And again, it has 6 bytes. And now if we run our program, let's first of all change our program so that it loads our new version of the program. So if I do a clear screen and list, you can see that line 60 here loads mctest1. We can change that to load mctest2, and I'll just do it here in the emulator directly. 60 load quote mctest2, and again I don't need any extension because I didn't save it with any extension, and I'll type comma AD because I still want to load it in the same memory location which is stored in our variable AD. And now if I run this program, it should print our new character on the screen, which is that right pointing arrow thing. So let's go ahead and run it. And there we go. We have these arrows filling both the border and the top left character position of that top hidden row. So I know it took a long time to go through all that information, looking at all the memory map and the different system variables and things to really get an understanding of how we can program in machine code for the Mattel Aquarius, although the actual method of creating and running the program is very simple once we're familiar with the information we need to know. The method is quite easy to use and very simple, so you might want to give this method a try if you just want to kind of experiment with assembly language on the Mattel Aquarius, running very simple programs like this. You can give it a try if you like. And then the next methods will be taking a look at some other ways we can create and run Z80 assembly language and machine code programs on our Mattel Aquarius. And now that we have this foundation of knowledge of these different technical aspects that we took a look at in this part of the video, it should be easier to understand going forward the different methods we're going to be taking a look at. So if this still sounds interesting to you and you want to create some machine code programs on your Mattel Aquarius, then stick around and we'll take a look at a few more methods, finally ending up with the method that I think is the most kind of versatile and easy to use method for creating my own games on the Aquarius. So stick around and we'll keep going.